right. Okay. So radioactive minerals, part 1, the oxide group, which is actually group 4 of the Strunz classification table, which includes not only oxides but hydroxides, tellurides, selenides, vanadides, and things like that. First of all, the definition of radioactivity. You can still see this, Steve?
Yes.
Thanks. Well, radioactivity is the emission of ionizing radiation or particles caused by the spontaneous disintegration of atomic nuclei. In nuclear physics and nuclear chemistry, a nuclear reaction is a process in which two nuclei, or a nucleus and an external subatomic particle, collide to produce one or more new nuclides. Thus, a nuclear reaction must cause a transformation of at least one nuclide to another. So that's how a nuclear reaction works. There are 4 common radioactive elements. Polonium, number 84 on the periodic table. Radium, number 88. Thorium, number 90. And uranium, number 92. Why I mentioned the 4? Well, we actually only have minerals with uranium or thorium. So those I will be talking about. But first we have to talk about radiation. The 3 types of interest regarding radiation in mineralogy, but in general life for sure, are alpha radiation, beta radiation, and gamma radiation. Alpha radiation. Well, if an atom loses 2 protons and 2 neutrons to form a helium-4 atom, are very large particles that can be stopped easily, quite easily. For example, by a sheet of paper put in front of it. So the radiation does not penetrate through the paper sheet. And this is the most common form of radiation. And because the particles are relatively heavy, they can easily be stopped. But they are harmful when ingested or inhaled. Beta radiation. Well, an atom emits an electron or a positron, which is an antiparticle of an electron. They are still small particles, but they penetrate further. So you have to use a thick book, a wall, aluminium wall, thick plexiglass, or sufficient distance to stop the radiation. And the nastiest one of them all is gamma radiation, which is electromagnetic radiation, and it consists of photons. Depending on the amount of energy per photon, or electron volt, it is determined whether something is gamma rays. Gamma radiation is less ionizing than alpha radiation, but it is difficult to protect yourself against it. It is possible, for example, by means of lead, concrete, or water. Gamma radiation penetrates deeply and causes damage to your body with prolonged or frequent exposure. So the longer you stay in gamma radiation, the worse it gets for you. It changes the cell structures in your body, and your organs get unhealthy doses, so they might stop working and things like that. So protection against radiation, well, alpha particles can be stopped by using a sheet of paper or a plastic box and in a drawer. Beta particles can be stopped by perspex or aluminium sheet, thick book, stone wall, or sufficient distance. And gamma particles can only be stopped by a significant amount of water or lead covering. I stole these pictures from the internet. This is the one with the thorium deposits. The thorium deposits mainly occur in the Northern Americas and Australia, versus the uranium deposits, which actually crisscross all over the world. So there's a lot more uranium deposits than there is thorium deposits. It explains why there are not that many thorium minerals and a lot of uranium minerals. So the oxides, hydroxides, etc., I will only discuss the ones I have. There are around 110 of them, 101 which contain solely uranium in its formula, 4 which only have thorium in its formula, and 5, which contain both thorium and uranium in its formula. So these are the ones I will discuss. There are 35 of them, so I have 35 of the 110 available minerals. And we start with becquerelite. Well, becquerelite is a radioactive orthorhombic oxide mineral, and the uranium in its chemical formula results from the hydrothermal alteration of uraninite and accounts for its radioactivity. Its color varies from yellow to orange, and it fluoresces yellow-green under shortwave UV. The crystal shape is mostly prismatic, but elongated lengthwise. It was named after the French physicist Antoine-Henri Becquerel, who discovered radioactivity in 1896. It occurs in oxidized portions of uranium deposits and also in some pegmatites. Well, my specimen is orange-yellow, and it consists of small crystals on sandstone matrix from the Pix Delta mine in Utah, USA. Peleitite. Peleitite is a radioactive orthorhombic oxide mineral, again orthorhombic, and it also comes from the hydrothermal alteration of uraninite. Its color varies from yellow to orange, and it fluoresces bright yellow under long-wave UV. The crystal shape is mostly pseudo-hexagonal, tabular, and elongated lengthwise. It was named after the Belgian crystallographer Valère Louis Billet. He didn't get to be that old, as you know, and it occurs in Permian Triassic conglomerates and sandstones. As we will find out during this presentation, there are a lot of Belgians who gave their names to uranium oxides. Here we see small yellow platy crystals on sandstone from the Eureka mine in Lleida, Catalonia in Spain. I did put up the field of view of all, but you can read that, so I won't mention that. It's all small, because it's all micro. Brennerite is a monoclinic radioactive oxide, and it also comes from the hydrothermal alteration of uraninite. The color is mainly black. Brown colors also occur, and it doesn't fluoresce, unfortunately. The material is mostly metamic, so it doesn't show any crystals, as grains and pebbles in veins in the host rock. It was named after the American geologist John Caspar Brenner, and he was a former professor and president of Stanford University. It occurs in granite pegmatites and in granitic gneisses, in silicified pebble conglomerates, hydrothermal quartz and calcite veins, and detrital in places. Here's my specimen. It fills up veins in the host rock, and it is black in form. This comes from the Konsku uranium deposit in the Alden Shield in the Sakha Republic of Russia. Calciosamarskite. Well, it's another orthorhombic oxide mineral, radioactive orthorhombic mineral, and again, the uranium comes from the hydrothermal alteration of uraninite. The color is black, and it doesn't also fluoresce. The material is mostly massive, and it was named after the Russian chief of staff of the mining corps, Colonel Vasily Evgrafovich von Samarsky-Bikovets. The prefix indicates calcium is dominant in the A side of the mineral. It occurs as an accessory mineral in Re-rich granite pegmatites, and then the B specimens. I don't have a photo from the colonel, unfortunately. He lived a long time ago. And this is my specimen. It's a massive piece of black material from Mitchell County in North Carolina. Cerianite Ce. Cerianite is a radioactive isometric oxide mineral, and it's a thorium mineral. The thorium in its chemical formula accounts for this reactivity, and its color varies from deep green, amber yellow, and it doesn't fluoresce. The material forms small octahedrons, It was named for its cerium contents, and it occurs in carbonatites and nepheline cyanides. My specimen consists of yellow microcrystals on matrix from the Clara mine in Wolfach in Germany. One of the few radioactive minerals from there. I also have a specimen from Morro do Ferro in Minas Gerais in Brazil, which is orange-brown in this case. The next mineral is clusenite. Well, as you can see in the formula, it has a lot of elements in it. It's a radioactive trigonal oxide mineral, and again, the uranium comes from the hydrothermal alteration of uraninite. The color is black, and there is no indication of any fluorescence at all. Not in long wave, not in short wave. The material is mostly metamict, but can appear as tabular crystals. It was named after the type locality, the Clusen Lake in Nendas in Valais in Switzerland. It occurs in alpine type clefts, veins in green schists, feces, metamorphic rocks. I have one with a damaged crystal on matrix from the type locality. Critonite. Critonite is a radioactive orthorhombic oxide mineral, and again, the uranium comes from hydrothermal alteration of uraninite. It is black in color and it fluoresces light green in shortwave UV. The material consists of elongated rhombohedral crystals, and it was named after Sir Alexander A. Crichton, a Scottish physician and mineral collector. Again, it occurs in alpine type fissure veins. This is a very small piece. It's only 3 by 2 by 2 millimeters. It consists of black crystals on I don't know what kind of matrix it is, and it comes from the Kabini Massif in the Kola Peninsula in the Murmansk region in Russia. Curite. Curite is a radioactive hexagonal oxide mineral. Again, uranium comes from the hydrothermal alteration of uraninite, and it's orange-red to orange, and it fluoresces light green under shortwave UV. The material consists of prismatic acicular crystals, and it was named after the French physicist Pierre Curie, who discovered the elements polonium and radium. It can occur in breccia, shale, or dolostone. Mine is a small piece again, 2 by 2 by 1 millimeter, and it shows orange, small orange crystals with light yellow becquerelite on matrix from the Streltsovsky molybdenum uranium ore field in Zabakarski Krais in Russia. Those names, who invented them? Davidite, Ce, is a radioactive trigonal oxide mineral. The color is black and it doesn't fluoresce. And the material is always solid. There's massive. It's not that does show any crystals. It was named after the English-Australian geologist Tanat William Ashworth David, who, among others, discovered the South Magnetic Pole on the first Antarctic Shackleton expedition. Nice fact. It occurs in granite pegmatites. Mine is a dark brown piece, massive piece from the Frykstad mine, Tuftane, from Agder in Norway. Then we have Davidite lanthanum, La. Well, it actually has the same name giver. And it occurs also in granitic gneiss and leucogranite. I have a piece with black in matrix with weathered brown Davidite. So the Davidite weathered further, it starts as black and then becomes weathered and it turns brown. And this is from Radium Hill in South Australia. This Davidite lanthanum comes from Erongo in Namibia, and it's black. It hasn't weathered yet. Next mineral is hydroxide. Hydroxide is a orthorhombic oxide mineral, and again, uranium comes from hydrothermal alteration of uraninite. Its color is all shades of green, mostly dark, and its fluorescence is non-existing. The material consists of prismatic crystals, and it was named after Belgian geologist Jean-Marie François Joseph de Ries, who studied the Shinkalobwe uranium deposit in the Congo. It occurs in the oxidized portions of a selenium-bearing copper-cobalt deposit, like the Musino mine in the Kolwezi district in Lualaba in the Democratic Republic of Congo. Euxenite, yttrium, or euxenite Y, is an orthorhombic oxide mineral, and it has uranium as well as thorium in its formula. The color can be black, greenish, or brownish, and there is no fluorescence, non-existent. The material consists of stout prismatic crystals or solid matter, and it was named after the Greek word euxenos, which means friendly to strangers. It occurs in granite pegmatites or as a component of detrital black sands. Well, I have a single black crystal, which is also a little damaged, but it comes from the pegmatite mine in Wyoming. This is a piece with crystals in matrix from the Val di Grana pegmatites in Piedmont, Italy. And this one comes from Canada, from the Matawan mine, and is solid in matrix. Okay, fluor-natural powder chlor. Fluor-natural powder chlor is not one mineral you commonly expect to inhabit radioactivity, but it does. It's an isometric oxide mineral, and the color can be brownish, yellow, or orange-red, and it doesn't fluoresce, unfortunately. The material consists of octahedral crystals or grains. The base name powder chlor comes from the Greek word pyro, which means fire, and chloros, which means green, which relates to the flame turning green in a blowpipe analysis. The sodium is dominant in the A side, and the fluorine is dominant in the Y side. It occurs as an accessory phase in niobium tantalum-rich alkali cyanide. This is one from the Poudret quarry, Mont Saint-Hilaire, with rhodochrosite on an azurine crystal. The next one is a brown-yellow one from the Kurishkin Loch in Chelyabinsk province in Russia. And this one I got from a friend of mine, André Westerman, who found it himself in the Água de Pau, in the Vale das Lombadas, in the Azores of Portugal. Guilleminite. Guilleminite is a radioactive orthorhombic oxide mineral. And again, uranium comes from alteration of hydrothermal uraninite. Color is a bright yellow, and its fluorescence is non-existing. The material consists of rectangular tabular crystals, and it was named after French chemist and mineralogist Claude-Jean Guillemin. And he was co-founder of the International Mineralogical Association. Fun fact. It occurs in the oxidized portion of copper cobalt sulfide deposits. Here we see yellow guilleminite with green martensite on matrix from the Musino mine in the Kolwezi district in the Congo. It's also the type locality for this mineral. Hainsite, another orthorhombic oxide mineral. Color is amber yellow, and its fluorescence is yellow-green under shortwave UV. The material consists of flattened plated crystals, and it was named after American geologist Jean Patrick Haynes. He exploited the mines in the Uravan belt and discovered several new mineral species. It occurs in an oxidized uranium deposit in mudstones and sandstones, like the one here from the Repeta mine in the San Juan County in Utah. Wolframite. Wolframite is a hexagonal oxide mineral, and its color is orange-yellow to canary yellow, and it doesn't fluoresce. The material, this is interesting, consists of hollow, elongated prisms. It was named after American geologist John Wilhelm Holford, and he significantly contributed to the mineralogy and geology of the Thomas Range in York County, Utah. It occurs as a pneumatolytic phase in rhyolite. Here we have a single wolframite crystal, yellow crystal, on quartz matrix from a centennial Eureka mine from York County, Utah, which is also the type locality. Excuse me. Iontinite. Well, another orthorhombic oxide mineral. The color is originally violet black. On exposure to air, it turns brown, and by dehydration, yellow into scoopite, and unfortunately it doesn't fluoresce. The material consists of flattened plates, but can also form elongated prisms. It was named after the Greek word iantinos, which means violet colored. It occurs as a secondary mineral in the unoxidized portions of uranium deposits. Well, here's the iontinite. It can be seen at the left side of the picture, left-hand side. It's brown, and some of it already dehydrated and turned into scoopite, which is yellow. This is from the uranium place in Menzenschwand in the Baden-Württemberg region of Germany. Cobiite Y. Cobiite Y, asymmetric oxide mineral. Color is black to dark brown, and it doesn't fluoresce. The material is mostly metamate, and it was named after the Japanese town of Kobemura, now known as Oyama-cho, Kyoto Prefecture. It occurs in granite pegmatites. Here we see the black metamate cobiite Y in matrix from Hiroshima City, Hiroshima Prefecture in Honshu, Japan. Leandrotite. Leandrotite is a trigonal oxide mineral. Its color varies from pale yellow to yellow brown, and it also doesn't fluoresce. When I started this, I was under the impression that every uranium mineral would fluoresce, but that's not the case. The material is mostly metamate and showing up as a crust. It was named after the French professor and mineralogist Georges Leandrin, who did a lot of prospecting in Madagascar. It occurs there in pegmatites in quartz mica schists. Here you see it as a crust of pale yellow on columbite manganese from the mica lode mine in Fremont County, Colorado. Martensite, another orthorhombic oxide mineral. Its color varies from yellowish green to greenish brown, and also doesn't fluoresce. And the material has always flattened prisms. It was named after the Belgian Director General of the Union Minière du Haut-Katanga, Aimé Martos. It occurs as an alteration product of selenium digenite by the oxidation zone of a uranium-bearing copper cobalt hydrothermal ore deposit. As you can see, it's the Mousonite mine again. This is a yellow-green twinned crystal. It's slight damage to the top, unfortunately, from the Kolwezi district in the Congo. It is also the type locality for this mineral. Masoyite, another orthorhombic oxide mineral. Its color comprises of all shades of orange, and again, it doesn't fluoresce. The material is tabular and can exhibit twinning. It was named after the Belgian geologist Gustave Massy, and as you can see, he also didn't get very old. He was killed during World War II, unfortunately. It occurs as a secondary mineral formed in the oxidation zone of uranium-bearing deposits. Here you can see the small, very small crystals, orange crystals on black uraninite from the Shinkolobi mine from Okatanga of the Congo. And again, this is the type locality for this mineral. Moctezumite, a monoclinic oxide mineral. Its color comprises of all shades of orange and it doesn't fluoresce. The material can be blade-like or forms rosettes, and it was named after the type locality, the Bambolita mine, Moctezuma, Sonora in Mexico. It occurs as a secondary mineral formed in an oxidation zone of a hydrothermal gold tellurium deposit. Here I only have a solid on matrix, orange Moctezumite, again from the type locality, the Moctezuma mine, because the Bambolita mine is now being renamed Moctezuma mine. Very difficult to change that every time. In Mexico. Rauwite is a radioactive amorphous oxide mineral, so it doesn't form crystals. Uranium in this comes from the hydrotermal alteration of uraninite again, and its color ranges from purplish black, brownish, or pale orange, yellow, and it doesn't fluoresce. And the material forms thin coatings. It was named after the chemical symbols it wrongfully presumed constituents like radium, uranium, and vanadium. And as you can see in the formula, it doesn't contain any radium. It occurs as an uncommon mineral formed in the oxidation zone of uranium, vanadium ore deposits. Mine comes from the Monument number 2 mine. It's a coating of orange-yellow. It says here very small crystals, but it doesn't form crystals. Maybe it does, I don't know. But at the moment, I think it's just a crust from the Monument Valley in Apache County in Arizona. Schmitterite. Schmitterite is a tellurite, which is not an oxide, but it belongs to the group 4 minerals. It's orthorhombic. The color is pale yellow and it doesn't fluoresce. This material forms thin flattened blades or rosettes. It was named after a Mexican mineralogist, Eduardo Schmitter Villela. He was professor at the National University of Mexico. This mineral occurs in the oxidation zone of a hydrothermal gold tellurium or uranium deposit. And I have pale yellow solid material on matrix, again from the Moctezuma mine in the Sonora in Mexico. And again, the type locality. Scoopite. Scoopite is another orthorhombic oxide mineral. Its color varies from amber yellow to lemon yellow, and it fluoresces yellow, unlike a long wave UV. The material forms tabular or short prismatic crystals, and it was named after the Belgian mineralogist Alfred Ferdinandus Maria Gislenius Schoop, professor at the University of Ghent. It occurs as an alteration product in hydrothermal uranium deposits or directly from eantinite. Here you see yellow scoopite, small crystals with cuprous cladoscite, green ones, and malachite, which is also green, but not visible in this picture, on matrix from the Moussonoy mine again, in the Kolwezi district of the Congo. Cinnahite, a trigonal oxide mineral. It colors mostly black and doesn't fluoresce. The material forms tabular crystals or rounded fragments. It was named after the Brazilian mineralogist Joaquim Candido da Costa Sena. He was professor and director of the School of Mines and also president of the state of Minas Gerais in Brazil. It occurs in granite or cyanide pegmatites or in a hydrothermal deposit. Well, my black small rounded aggregates come from Gros Steel in Colonges in Wallis in Switzerland, and it's on matrix. Stuttite, a monoclinic oxide mineral, and it comprises all types of yellow. and it fluoresces pale yellow under long wave and short wave UV, both. The material forms acicular flexible crystals or radial sprays, and it was named after the British geologist Franz Edward Studd. He was a geologist for the Tanganyika Concession Limited and produced an important geological map of Katanga. It occurs in the oxidized zone of some uranium-bearing deposits. I have one with very small acicular crystals on matrix from the mentioned Strunz in Baden-Württemberg, Germany. Another thorium mineral, thorianite, is a isometric oxide mineral, and its color ranges from black to dark reddish brown and even gray, and it fluoresces green under long wave and short wave UV. The material forms cubic crystals, sometimes rounded when waterborne. It was named after its thorium contents, which makes sense, and it occurs as an accessory mineral in granite pegmatites, carbonatites, and serpentinitites. This is my specimen. It's small, 3 by 3 by 3 millimeter, and unfortunately, when I dropped the box, one of the cubes broke off, and I gave that to a friend of mine. So I just have the one on the right. Comes from the Yanes mine in Pontiac in Quebec, in Canada. Uraninite, yeah, well, I mentioned it before. Isometric oxide mineral. It color varies from black to greenish, and it doesn't fluoresce. It forms cubic crystals, but can also be botryoidal. Of course, it was named after its uranium contents, and it occurs in granite and cyanide pegmatites, in hydrothermal tin, cobalt, nickel, bismuth, silver, and arsenic, and other sulfide veins, in sandstone-hosted uranium and vanadium deposits, and in uraniferous conglomerates. This one is, well, it says black spherical, it's actually botryoidal, with calcite on matrix, and it comes from the Predborice deposit in the central Bohemian region of the Czech Republic. Uranopolycrase is a reactive orthorhombic oxide mineral. Its color is red-brown and it doesn't fluoresce. The material forms elongated tabular crystals, and it was named as the uranium-dominant analog of polycrase Y. It occurs in pegmatites with abundant niobium and tantalum minerals and zeolites. Here you have some small red-brown crystals in the cavity and matrix from the San Piero in Campo, from the island of Elba in Italy. Van den Brandeite. I say it in Dutch because it's actually Belgian. It's a triclinic oxide mineral. Its color comprises all types of green, and it doesn't fluoresce. The material forms somewhat bladed crystals. It was named after the Belgian geologist Pierre-Jean Justin van der Brande for the geological survey of Katanga, who discovered the deposit at Katanga. As you might well know, the Congo was a former colony of Belgium, so that's why there are so many minerals named after Belgian geologists from the Congo. It occurs as secondary mineral in the oxidized zone of hydrothermal copper-bearing uranium deposits. I have a specimen with dark green crystals with caesolite on matrix from the Musena mine, again from the Congo. Van den Drieseite, another orthorhombic oxide mineral. Its color is orange to amber brown, and again it doesn't fluoresce. The material forms flattened crystals, and it was named after Belgian geologist Adriaan van den Driessen, who was also a professor at the University of Ghent, and well, he died even younger than the other one. It occurs in the oxidation zone of uranium-bearing mineral deposits. I only have microcrystals, orange-yellow microcrystals on matrix from the Novazza mine in Bergamo, Lombardia, Italy. Bosendorfite, another orthorhombic oxide mineral. It color varies from orange red to bright red, and also this mineral doesn't fluoresce. The material occurs as spherulites and crystalline incrustations, and it was named after its discovery locality, Wilsendorf in Bavaria, Germany. It occurs as an alteration product of uraninite in the oxidation zone of uranium-bearing mineral deposits. I only have a very small solid grain, orange grain, from the Streltsovsky molybdenum uranium ore field in Zabaikalsky Kras. It's only 1 by 1 by 1 millimeter. But as a good micromounter, that suffices. Yttriocresite, why? It's another amorphous oxide mineral. The color is black and it doesn't fluoresce. The material is metamic, as actually amorphous means. And it was named after its chemical composition containing yttrium, and from the Greek word of krasis, meaning mixture, due to the many other elements present. I beg to differ, there's not that many, but okay. It occurs in complex granite pegmatites. I have a piece with a solid black material in matrix from Kragerø in Norway. Yttriotantalite, why? Well, it's another orthorhombic oxide mineral. The color is brown black to black and it doesn't fluoresce. The material forms prismatic and tabular crystals, but is mostly metamic. Don't know why it says metamic twice. It was named after its chemical composition containing yttrium and its similarity to tantalite. It occurs in complex granite pegmatites. Here I have a piece with some lepidolite, a small brown piece with some lepidolite on quartz from the Hugtveit feldspar quarry in Agder, Norway. And so far my presentation.